Kavin Kumar. This is my ICP-4. So ICP-4 first question is about finding the correlation between two columns for the Titanic dataset. So before going to the question, let's see what the correlation is. So the correlation says that when one variable increases, the other also increases. A variable can be a feature or a target or anything. And the negative correlation says that when one variable increases, the other decreases. And when there is no pattern, then it is called as no correlation or no connection between the two variables. So now our description about the Titanic dataset. The Titanic dataset has several columns describing the Titanic scenario to study about the analysis of what sorts of people were likely to survive. One such scenario which we took to find the correlation between two columns, sex and survived. So the first step is to import all sort of libraries. We use pandas libraries to read the CSV file, and we found the correlation between the feature class X and target class survived using the grouping method and finding the mean and sorting. So if we run this code, we can find the correlation between the two columns. It says that most of the females have survived, but most of the males did not. So it's 75% of people who survived is female and 18% is male. Now coming to the second question. Second question is about implementing the naive Bayes on the dataset provided. So this dataset has the description about the class, about the elements contained in the class, RI, NAMG, and all other elements. So before going to this question, let's see what's naive Bayes is. So naive Bayes is, we say it's Gaussian naive Bayes because this is a normal distribution. So we find posterior probability of each of the classes, where posterior probability is like it's a product of likelihood and its class prior probability by predictor prior probability. So here first we import the library, load the class dataset using the pandas pd.read CSV, and select the feature columns. So the feature column is going to be RI, NAMG, aluminum, etc., and the target column will be the type. So and we select the target column. So and split the data set into 70% and 30%, 70% for training and testing for 30%. So to see the training set and test it, we print them and we define a model for Gaussian NB, that is Gaussian naive Bayes, and train the model on the trained dataset using the fit method, and test the model accuracy using the test set. So this is the training where we have taken X train and Y train, that is 70% of the dataset, and X test and Y test to find the accuracy on the test dataset. So this is going to be our target class, the classification class. So running this code, naive Bayes. So the training is going to be, it's on 149 rows and 9 columns, and the target is going to be the 145 rows, 149 rows with 1 column, and same for the test dataset with 65 rows, 65 tuples. So we got accuracy of naive Bayes as 0.58 and on test set 0.46. This is because the dataset or tuples in the training set is already seen by the model, but it's not seen on the test set. So that's why there is a huge difference between the accuracy on training set and test set. Now coming to implementing the linear SVM. So coming to linear SVM, well, in linear SVM, if we have several classes, let's say for an example, we have two classes, we find vectors which separate them in the regions is called as vectors, and using these vectors we define the SVM. And coming to the coding part, so first we import the libraries, load the class dataset, and select the feature column and select the target class and split the dataset as we did earlier, and print the data shape. And now we create an SVM model using linear SVC from the sklearn library, and train the model using the same fit method and print the model accuracy. Now printing the SVM. So we have got 0.28 as accuracy on training set and 0.17 on test set. So we could make a conclusion that the dataset is not linear, because if it is linear we would have got an higher accuracy. Now coming to the RBF kernel, where RBF kernels are applied on non-linear datasets. For example, if you have a dataset something like this which is not linear, where two datasets are not the classes are not linear, so applying SVM on using the RBF kernel, the same thing, import libraries, loading, splitting, etc. At last we define the model using the RBF kernel, where we say kernel is equal to RBF, and if we run the SVM code with RBF kernel, we have got 0.77 and 0.63 on training set and test set respectively, which is a very huge difference from 0.2 to 0.1 to 0.77 to 0.63. So we have made a conclusion that this dataset is not linear. It is not linear. So the glass dataset is non-linear. That's why we see a huge difference. That's it about the ICP-4. Thank you.